scientific ladies, reports in the New York Daily Tribune, and mentions in Canadian, Scottish, and German journals. Her paper was also published in the American Journal of Science and Arts, alongside Elisha's far less significant work on a similar topic. Elisha's paper was republished in the London-based Philosophical magazine, but whoever picked it must have taken a pass on Eunice's. A fire at the Smithsonian in 1865 destroyed much of the couple's work and saw Eunice's research on carbon dioxide reduced to a few scant references, largely forgotten until 2011, when retired petroleum geologist Ray Sorensen stumbled across it. A few years later, climate scientist Catherine Hayhoe dug it up after a colleague asked why there were so few women in the history of the field. This in turn saw it reported in the climate change press, where the story of a forgotten female scientist who had found a link between carbon dioxide and a warming climate back in the 1850s hit a nerve. And yet for Eunice and her contemporaries it was all theoretical, a contribution to our burgeoning understanding of gases and heat. It would be another century before anyone started to worry about it. In 1956, oceanographer Roger Revelle was one of several American scientists looking at the topic of carbon dioxide relative to climate change afresh. In the intervening years, there'd been a little more scientific research on the topic. There'd also been a lot more carbon dioxide emitted. The problem was rather less abstract for Revelle than it had been for Foote. He'd been studying the ways in which oceans absorbed carbon dioxide and realised it wasn't nearly as much as had initially been imagined. Moved by the consequences of his findings, he concluded his paper with a note that humanity was carrying out a large-scale geophysical experiment. At first, Revelle saw this experiment with the Earth's climate as a bit of an adventure, as just a fleeting moment in time, telling Congress in 1956 that it was an experiment which could not be made in the past because we didn't have an industrial civilization, and which will be impossible to make in the future because all the fossil fuels will be gone. Like many other scientists of his time, Revelle believed nuclear energy would supersede fossil fuels in a few decades, solving the problem. But that was one prediction he was wrong about. As the 1960s and 1970s rolled on, the evidence for global warming mounted. People started to worry too, but they didn't turn down the gas. Quite the opposite. Revelle's experiment line would be repeated many times, including by UK Prime Minister Margaret Thatcher in an autumn 1988 speech to the Royal Society. We have unwittingly begun a massive experiment with the system of this planet itself. By this point, Revelle and his colleagues had studied further and checked and rechecked each other's work, and there was a strong scientific consensus that if carbon emissions continued at their current rate, global temperatures would get very uncomfortable by the 21st century. Today, we're living in that uncomfortable future that people in the 1960s, 1970s and 1980s used to worry about. Although there's been progress when it comes to clean energy technologies and mechanisms for building climate policy have been set up, the UN Climate Convention, for example, most people living on Earth are a long way from safe. For anyone who needs a quick recap on the basic science, the way in which the Earth's atmosphere traps some of the sun's energy is usually called the greenhouse effect. Strictly speaking, greenhouse isn't the best metaphor, and it's more as if the planet is wrapped in an insulating blanket of gases. Still, somewhere along the way, someone said greenhouse, and it stuck. The main gases in this imaginary greenhouse are water vapour, carbon dioxide, methane, ozone, nitrous oxide, and CFCs. In some respects, the blanket they provide us is a good thing.